Good morning everyone. Today we will like to present our CAD mini project, which is automatic curtain roller box. In this course, we have two lecturers, which is Dr. Sukhairi and Dr. KAMARUL, and the table below shows our team members in this mini projects and their roles. First, I would like to introduce our mini project. The automatic curtain roller system combines a motorized mechanism with a PCB-based control unit for reliable, compact operation. It supports both automatic and manual control via a push button, offering user flexibility by regulating light and temperature. It improves comfort and energy efficiency in homes and offices. The objective of this mini project is to design and develop an automatic curtain system that can be operated using a push button for ease of manual control. And the second one is to construct a functional PCB circuit that integrates key components such as a microcontroller, motor driver, and power supply for controlling the curtain mechanism. And the last one is to automate the open and closing of curtains using an electric motor controlled by user input through a push button. The design methodology that I have used in this mini project are problem identification and requirement analysis, mechanical design, PCB integration and electronic design. The fourth is simulation and motion analysis, and prototype assembly and testing, and the last one is evaluation and final adjustments.
Hi, my name is Mohammed ALHAMFARIS and I will present about mechanical details of the project. First is the body case of the box, and I used ABS plastic for the material. All the parts in this project are included the isometric views, front view, top view and side view with the detailed measurements. The second one is front cover with ABS plastic for excellent durability. Third is PCB board with phenolic resin that is electrically insulated. Fourth is battery holder with ABS plastic. Fifth is IC and push button with ABS plastic. Sixth is rectifier and voltage regulator with PC or ABS plastic. 7 is stepper motor with steel for strong material in motor housing part. 8 is blind gear with nylon for strong and flexible material. Front button using ABS plastic. 9th is screw with stainless steel material for strength. So this is the drawing views including all the components and the PCB board. Next is the assembly model with the enclosure. Then this is the exploded assembly model, which have the all components and enclosure with the BOM list for details. To integrate the mechanical parts and the electronic parts, I place all the electronic parts and assemble it with the PCB board as the grounded material, then enclosure with the screws attached.
Now I will explain the electric design part of our project. This includes the main control circuit, the powers and change the direction of the DC motor. We used a simple logic-based system without any programming. Let's take a look at symmetric diagram. This is the electric circuit used to control the 12 DC motor. We use two push buttons, switch 1 and switch 2, to control the direction of motor. The signal from the switches go through NOT gate and logic gate IC. Then the output control 4 transistors arranged in an H bridge, which allows the motor to spin forward or reverse. The power is supplied by two 6-volt batteries in series. giving 12 volts to the motor. This setup is simple and it doesn't need any programming, just for logic control. In this one PCB layout, this is 2D view. This is 3D PCB design of our circuit. On the top view, we can see the batteries holders, IC, resistor, and connectors for the push buttons. The bottom view shows the stepper motor connection with the 5-volt input. This PCB layout helps us to arrange and solder all the components properly for a compact design.
As the team leader in this mini project, I have learned the importance of clear communication, time management, and delegation. I also balance technical understanding with leadership responsibilities. The third one is I encourage team participation by listening to ideas and promoting ownership. I also gain experience in project scheduling and resolving conflicts. And the last one is I build confidence in leading group efforts.
For lifelong learning as a mechanical designer, I used Autodesk Inventor to design the components and arrange them onto a PCB layout. Before I design, I measure the components according to the datasheet of the components. I used extrude, revolve command and shell command to make hole. I used realistic materials and colors to show the difference between the mechanical and electronic parts. Then I also learned to design the appearances of the screw, which is the polar array, polygon and thread command. For the assembly parts, I used constraints and apply both mate and insert command to secure the parts. When designing the enclosure, I made sure there was enough space for wiring and easy assembly. So this project taught me how important it is to design for real-world use, making sure parts fit and work well together.
Electronic designer, I was responsible for creating the schematic and PCB layout using LTEM circuit maker. I learned how to choose the right components based on voltage, current, logic type, and package of SMD or DIP. I also learned to route power and control signals like VCC, GND, and logic lines carefully. Using AND gates and designed simple logic control that responded to button inputs, I made sure that schematic matched the physical components carefully and using the right footprint. For high current path like motors, I used the right track, width, and spacing, also using 3D view tools to check that components would fit properly inside the casing. This project taught me how small details, like direction of a part or the space between pins, can affect whether the PCB work or fail.
The first challenge that we face in this mini project is mechanical alignment of curtain movement, and the solution implement is we improve our ideas comparing by before, which is using a stepper motor, and we also use a gear which is same size with the big curtain. This idea is decided after discuss with my team members.
As for the challenges during my part, the first is during the assembly constraints. To solve it, I analyze the error of the constraints and confirm the correct midpoint or center part, and I use the correct command of the mate and insert.
And then the next challenges is PCB size and component placement. And what we do is we measure the PCB and design the box casing precisely, adding space between components to prevent assembly errors.
The second challenge is to select the right components for the compatibility. To solve it, I refer to the component datasheets and design with the correct and suitable measurements.
That's all from us. Thank you.